This is AP Calculus 2.8, the product rule. In the product rule, we're going to have two functions within the same function, and they're going to ask us to find the derivative of that new function. So we're going to let u and v be functions. And in these problems, you're going to have f of x equals u times v. In other words, you're going to have a function times another function to make up our new function that we're finding the derivative of. Okay? If you have something like that, you have to use the product rule in order to solve it. And the product rule is f prime of x, when f of x equals u times v, and u and v are functions. F prime of x equals u prime times v plus u times v prime. So you take the derivative of the first function, multiply by the original second function, and then add that to the original first function times the derivative of the second function, and you will get your final derivative using the product rule. Now, if you have something like this, if you were to have something like f of x equals 2x plus 5 times 3x minus 4, you could use the product rule on that. You could take the derivative of this times this original plus this original times this derivative, and you would get the same thing as if you just FOILed those and then took the derivative of the answer. So if I had something like this where I had two binomials and they asked me to find the derivative, I'm probably going to FOIL it and then find the derivative using the power rule, because I think that's just a little bit easier and it's less algebra to deal with. But sometimes that's not possible. You may have something like this where you've got f of x equals 2x times cosine 5x squared plus 2. And hopefully you remember from algebra, there is no way to combine those and make one function out of them together. You can't FOIL it. You cannot distribute the 2x into the angle part here. That's just completely wrong. So in this one, this is a perfect example of when we have two functions within the same functions. They're multiplied together. So we've got two functions here within the same function multiplied together, where we're going to have to use the product rule in order to solve that. So if I do that, f prime of x. So if I take the derivative of this using the product rule, I'm going to take the derivative of the first part, which derivative of 2x is 2. I'm going to multiply that times the original second part, which is cosine 5x squared plus 2. Then I'm going to add that to the original first part, which is 2x, times the derivative of the second part. Now, the derivative of cosine is negative sign, so that's going to make this a negative, and it's a negative sine of the angle part. I'm going to leave that right there, and then I have to multiply in front of that sign by the derivative of the angle part, which would be a 10x. So I'm going to place the 10x in front. So I've taken the derivative there. So I've got, just to review that again, the derivative of the first part times the original second plus the original first times the derivative of the second, which forced that plus to be a minus. The derivative of the second is sine 5x squared plus 2 times the derivative of the inside part, 10x. And then at this point, if I can combine anything, I would combine, I would simplify whatever I have. So I've got 2 cosine 5x squared plus 2 minus 20x squared sine 5x squared plus 2. You can leave it like that, or you could bring the 2 out if you want to. Really, there's no reason to bring the 2 out. If they're just asking us to find the derivative, I would just leave it like this. If they ask me to go further and like find maybe the slope of the tangent line or horizontal tangent lines, then I might want to factor some things out to simplify it a little bit, to make it a little bit easier to do that. But right now, all they asked for was the derivative. So just leave it like this. You're good. That should be all you need to do. Here I've got 3 more functions using the product rule. In the first one here, g of x equals 4x squared times e to the 3x. So my first function is the 4x squared. The second function is e to the 3x. Sometimes they will separate your two functions by parentheses, but they don't necessarily have to. You need to be able to understand what the two functions are and how to separate them sometimes. So if I do this one, they want me to find g prime of x. We're going to have to use the product rule. The derivative of the first thing is 8x. We're going to multiply that times the original second part plus the original first part, 4x squared, times the derivative of the second part. So the derivative of e to the 3x is e to the 3x times 3. And then we just simplify. So we've got 8x e to the 3x plus 12x squared e to the 3x. Okay? So that's all you would have to do there. If there are any like terms, you could add them together. Another thing you could do if you want to, you could take out a 4x e to the 3x, and then you would have a 2 plus 3x left inside. Not necessary to do that, but if you like to separate things out, there's nothing wrong with that. In the next one, we have f of x equals 5 to the x times natural log of 2x squared plus 4x. So the first function is 5 to the x. The second function is that natural log function. And so we have to take the derivatives separately. So if I find the derivative of that, f prime of x, for the derivative of the first part, we're going to have, remember, the natural log of 5 times the original 5 to the x times the derivative of the x part, which would just be 1. And then we're going to keep the second function. Let me get rid of this. Keep that second function, so that's going to be natural log of 2x squared plus 4x. Then we're going to put plus, and we're going to keep the first thing, the original, 5 to the x. Then we're going to take the derivative of the natural log part. Well, the derivative of a natural log is the derivative of this part over the original. So the derivative of this, the x part, is 2x squared. The derivative is 4x plus 4. And that would be all over 2x squared plus 4x. And then at this point, I would leave it like this. Unless they ask you to do something else with this, you are perfectly fine leaving it like this. If you try to combine these two things together, that would mean that you have to get a common denominator here, which would get pretty difficult pretty quickly with the algebra. And that, again, I've said this before, the calculus is usually not too bad, but the algebra associated with it can be very tedious. So I would leave it like this, unless they ask you to do something else with this function, like find the horizontal tangent line or the slope of the tangent line or something like that. There is really no need to get a common denominator and do that. Even if they ask you to find the slope of the tangent line for this one, that would be just a matter of plugging an x value in. I don't even think I would simplify it for that. I would just plug in at this point. Just be real careful to make sure I'm careful with the math as I plug those numbers in. But you only want to simplify these things if it's necessary to simplify because of what they're asking you to do afterwards. So again, don't simplify that, just leave it like that. Make it simple on yourself, make it a little bit easier on yourself. All right, for this one, here we have a trig, another trig function, f of x equals 2x, that's the first thing, times the second thing, sine of 4x plus 1. And so if we find the derivative of that, again, we're going to use the product rule. The derivative of the first part is 2 times the original second part, that's sine of 4x plus 1, plus the original first part, which is 2x, times the derivative of the second part. The derivative of sine is cosine, and now that's cosine of 4x plus 1, and then we have to take the derivative of the angle part, which is 4. And then I would just simplify that. That is 2 sine 4x plus 1 plus 8x cosine 4x plus 1. And that's really all I could do there. I guess I could take a 2 out, but that's all I could do. A common mistake with trig functions is sometimes students look at that and they say, oh, they have a 4x plus 1 in common, I can take it out. Well, no, algebraically you can't. The sine function has to have that angle part attached to it. If you try to factor it out, you have changed its value. So you can't do that. Same thing with the cosine of 4x plus 1. You would be changing the value of that function if you try to take it out. It has to be there. Your angle part has to be attached to your sine and cosine. So you cannot do anything else with that other than take a 2 out, and that's not really going to help you with anything. Here is an application of the product rule. Here they're asking me to use the chart to answer the question, and they're telling me that p of x equals f of x times g of x, and they want me to find p prime of -2. And then they give me a chart with some values in it. Well, they ask me to find p prime of x, and p of x is the product of two functions, then p prime of x would be using the product rule to find that derivative. So the derivative of the first thing would be f prime of x times the original second, g of x, plus the original first, f of x, times the derivative of the second, g prime of x. And then all I have to do is plug -2 in for every x. So p prime of -2 would be f prime of -2 times g of -2 plus f of -2 times g prime of -2. And then I can use my chart to fill in to this information. So -2, f prime of -2 is 3, g of -2 is 2, f of -2 is -1, and g prime of -2 is -2. And then I just do a little bit of math there. So 3 times 2 is 6, plus -1 times -2 is 2. So 6 plus 2 is 8. So p prime of -2 is 8. This is very similar to the last example, except here, instead of giving us a chart, they've given us a graph to look at. And they're telling us here that h of x is equal to f of x times g of x. This is your f function, and this is your g function. And they want us to find h prime of 1. Well, in order to do that, and I'm going to put it up here, h prime of x is the derivative of the first part, f prime of x, times the original second, g of x, plus the original first, f of x, times the derivative of the second, g prime of x. And if they're asking us to find h prime of 1, they want us to put a 1 in for every x in my function. So if I do that, I'll put 1s in all of these. And then we're going to use the chart, or we're going to use the graph to figure out what these values are. Now, that's a 1. And then we're going to use the graph here to figure out what all these numbers are. Now remember, f prime is the slope at 1. So we need to look at the f function at 1 and figure out what the slope is right there. Well, if I look at that, it looks like the slope is 1 over -3, so -1/3. What is g of 1 when x is 1? Well, that would be -1. F of 1 at 1, the f function is 3. And then g prime at 1, I forgot to put my 1 in there, g prime at 1 is, looks like 1 over 2, 1/2. And then we just do the math. So -1/3 times -1 is 1/3, plus 3 times 1/2 is 3/2. And then if I get a common denominator, let's see, that would be 2/6 plus 9/6, and that would be 11/6. So h prime of 1 is 11/6.